All right, good morning, guys. So this video is 6.5. We are going to be simplifying expressions that have rational exponents here. So basically what we're doing here is we're using our exponent rules with rational exponents. Okay. Your module in Canvas may be called slightly different, but it is 6.5, and we are going to be simplifying rational exponents. Exponent rules with rational exponents. Okay, so basically none of our rules have changed. They're all exactly the same, but now we just have some rational exponents. So these k's right here, we have k to the 1/3 and k to the 1/4. We just basically want to condense this so that we only have one k base of k. Remember, if I have two things with the same base multiplied together, I can just take and add their exponents together. So this is going to be equal to 2, we have our big 2 out here, times k, and k is going to be raised to the 1/3 plus 1/4 power. So exactly the same rule. If this would have just been like 2 times k squared times k to the 4th or something, we would have just gone ahead and added the exponents to get 2k to the 6th, right? Same thing, but now we just have rational exponents. In order to add two fractions together, we have to have a common denominator, right? So in order to get a common denominator, I'm going to have to multiply this side by 4/4. Remember, I'm just multiplying this ratio 1/3 by 1, so 4/4 is just equal to 1. So I'm not changing the ratio, but I'm just making it so that the denominators will match. So I need to do the same thing over here, except for I'll need to multiply by 3/3. This gives both of our fractions a denominator of 12. So this would be 2 times k raised to the 4/12 plus 3/12. So remember, when you are multiplying fractions, so first I'm multiplying 4/4 times 1/3. I multiply the numerator times the numerator, so that's 4 times 1. That gives me the 4 on the top. And then on the denominator, I do denominator times denominator, so 4 times 3 is 12. And then over here, 1 times 3 is 3, 4 times 3 is 12. So 4/12 plus 3/12. Now that that denominator is the same, I can go ahead and add 4 and 3 together. So this would be 2k raised to the power of 7/12. Okay, so I am not trying to do anything like what we did yesterday. I'm not going to be actually changing forms here or trying to evaluate the roots. All I'm trying to do here is condense these so that my variables, or sorry, not the variables, but the bases are just condensed into one here. It's okay to have a fraction in your denominator. Remember, if you get a negative, you'll need to move it down to the other part of the fraction. But that's the basics of what we want to do today. So let's go ahead and try another one. So here I have k squared times 3k squared times k to the 1/2. So the 3, we can just pull that out front. There's 3 k's multiplied together, and I would just go ahead and add their exponents together. So to get the exponent on k, so 2 plus 2 plus 1/2. So this equals 3 k to the 4 plus 1/2. Now again, I need to get a common denominator here, so I can think of 4 as 4/1, and this one would need to be multiplied by 2/2 in order to get the same denominator as 1/2. So this would equal 3k to the 8/2 plus 1/2, which would equal 3k to the 9/2. 8/2 plus 1/2 is 9/2. Okay, so here I'm just going through examples. These are all product rules here, right? On this one, I would need to take and multiply 4 times 3 together to get 12. I have x to the first power times x to the 5/3 power. So x is going to have the exponent of 1 plus 5/3. So that would be equal to, remember I need to get this 1, think of it as 1 over 1. I need to multiply by 3 over 3 in order to get that common denominator. Wow, my 12 is lovely. So this would be 12x, we got 3/3 plus 5/3 is our exponent. So my final answer here is 12x, 5 plus 3 is 8. So raised to the 8/3 power. All right, so let's try one with our quotient rule now. So I have 3v times 2v squared on the top. On the bottom, I have v to the 5/3 times 4v. So what I'm first going to do here is I'm going to just simplify the numerator separately, and then I'm going to simplify the denominator. And then once I've done that, then I will cross over between the two. So in the numerator, I have 3 times 2, which is 6. I have v to the first times v squared, which would be v to the third. On the bottom, I have 4 out front, and I have v to the 5/3 times v to the first, which means the exponent on this v will be 5/3 plus 1. So I can reduce the 6 over 4 because they both have a factor of 2, so that would reduce to 3 over 2. So I've still got v to the third up here. On the bottom, 5/3 plus 1, I think of it as 1 over 1. Get a common denominator by timesing the top and bottom by 3. So this would be 5/3 plus 3/3, which is 8/3. And now I can use my quotient rule. Remembering the quotient rule, if I have x to the 5th, divided by x squared or something like that, I'm going to take the top exponent and I'm going to subtract the bottom exponent. So this would give me x to the third, right? So I'm doing the same thing here. The 3 over 2 will stay, 3 on the top, 2 on the bottom. But v is going to have the exponent of 3 minus 8/3. So again, I need to do 3 minus 8/3. I think I'll move over here to do that. So think of it as 3 over 1 minus 8 over 3. Wow, this marker is slow. So now I'm going to multiply it over here by 3 over 3. So 9/3 minus 8/3. I don't know why we are suddenly zooming. So 9/3 minus 8/3 is 1/3. So I had 3v to the 1/3 on top because I just got my exponent of 1/3, and then the 2 on the bottom. That little thing, that little guy's a 3. Okay, so let's go ahead and try a couple more examples like that or similar to that. Okay, let's see. So we have 4x to the 3/2 times 2x. So I'm going to ignore the bottom for a moment and I'm just going to simplify the top. So 4 times 2 equals 8. That was supposed to be an equal sign. And then x to the 3/2 times x means that x's exponent is going to be 3/2 plus 1. Right? This one has an exponent of 1, and I'm just adding those two exponents together. And then on the bottom, I have 3x to the 1/4. 1 over 1, I need to get a common denominator of 2, so I'm going to multiply this by 2 over 2. So 3/2 plus 2/2 is 5/2. So 8x to the 5/2 on the top. On the bottom, 3x to the 1/4. Now I want to see if I can reduce my fraction, but 8 over 3 does not reduce, so 8 will remain on the top and a 3 will remain on the bottom. But x is going to have the exponent of 5/2 minus 1/4. And then just a 3 on the bottom. So 5/2 minus 1/4. Here I would have to multiply by 2 over 2 in order to get that common denominator. So that would give me 10/4 minus 1/4. And so the exponent on x on the top here is going to be 9/4. So we've got 8 x to the 9/4. If I could reduce 9/4, I would, but it won't reduce, over 3. Okay. All right, let's just try another one. I think we're going to just go ahead and skip. These are exactly the same, and we're going to see that we now have some with the power property. So I've got some parentheses here. On these, you technically could, I guess I shouldn't say technically, you can do one of two things. You can either multiply every exponent inside the parentheses by 2 first, or I can reduce what's inside these big parentheses first and then apply the second power. So it doesn't really matter as long as you're careful about doing it correctly. You'll get the same answer in the end either way. I'm going to simplify what's inside the big parentheses first, and once that's simplified, then I'm going to apply that squared outside. So the first thing I want to do inside here is I want to take this x to the 1/2 that's raised to the 2/3, and I want to multiply those two exponents together. Remember, if you have an exponent raised to another exponent, they get multiplied together. So this is going to be x squared times x to the power of 1/2 times 2/3. And then all of that's still, of course, squared. Okay, so remember when you multiply two fractions together, you just take the numerator times the numerator, and then you also take the denominator times the denominator. So this is going to be x squared times x to the power of 2 over 6 raised to the second power. Now 2 over 6, that simplifies to 1/3, right? 2 over 6 reduces to 1/3. So now I have the x squared times x to the 1/3 on the inside. Oh, this marker is frustrating today, I apologize. And then we're squaring all of that. So again, let's multiply these inside. So I'll have x to the power of 2 plus 1/3 And I need to get a common denominator, so I am going to multiply this side by 3 over 3 to get those to match. And of course I still have the squared outside. So this would be 6/3 plus 1/3, which would be 7/3. And then that is squared. So x is going to have the exponent of 7/3 times 2. So think of it as 2 over 1. 7 times 2 is 14. And 3 times 1 is 3. So x is raised to the power of 14 over 3. Totally can't read that, but that's what it says. X to the 14 over 3. Wow. Okay. All right. You'll just have to take my word for it. Okay, so let's go ahead and try just like one or two more, and then we will be done for today. Okay, so here I have n to the 4/3, and I'm raising it to the 5/3. So I would want to go ahead and multiply 4/3 times 5/3. That's going to give me, just for this first expression, would be n to the 29ths. 4 times 5 is 20, and 3 times 3 is 9. And then I'm going to times that by n to the 7/4. So now I'm going to add the exponents together here. So 29ths plus 7/4. In order to add those, I'm going to need that common denominator. And so because 9 and 4 have no common factors, I'm going, oops, not times, but plus. I'm going to have to times 20 over 9 by 4 over 4, and I'm going to have to multiply 7/4 by 9 over 9. So 4 times 20 is 80. So this is going to equal n to the 80, goodness, and then 4 times 9 is 36. And then I'm timesing this by n. 7 times 9 is 63 over 36. That's a 3, not an 8. So 80 plus 63 would be 143. Oh man. 143 divided by 36. That's my exponent on n. I apologize for that. Okay, this marker's crazy today. So n to the 143 over 36. Let's see, 3 is not going to go evenly into that. You could see if that would reduce at all. I'm not sure if it will or not, to be honest, but we're going to leave it like that. My marker's just not cooperating well enough. Let's see if there's one that looks, oh, they're pretty much all the same from there. So let's just do one more, and this will be our last one. So n to the 1/2 squared, if I multiply 2 over 1 times 1 over 2, that's going to give me n to the 2 over 2, which is just n. And then I've got times n to the 1/3. So if I multiply 1/2 times 2 up here, I'm just getting a first power, right? So now this is going to equal n to the 1 plus 1/3. The 1's going to get multiplied by 3 over 3 in order to get the common denominator. And so 3/3 plus 1/3 is equal to 4/3. So n is going to have the exponent of 4/3. And that's it for today, guys. Good luck on the homework. If you have any questions at all, please email me and we can get you some help. Have a great day, guys. See ya.